Okay. In this video, I am going to discuss a technique in integration in which the integrand will be expressed in terms of or as a sum of partial fractions. So, how do we integrate rational functions? Or this is about the integration of rational functions by partial fractions. A rational function was defined as one which can be expressed as a quotient of two polynomial functions. That is, the function h is a rational function if h of x is equal to p of x over q of x. So it's a quotient of two polynomial functions, where p of x and q of x are polynomials. So if the degree of the numerator is not less than the degree of the denominator, we have an improper fraction. And in that case, we are going to divide the numerator by the denominator until we obtain a proper fraction. So what does this mean? A proper fraction is one in which the degree of the numerator is less than the degree of the denominator. For example, this one. This is an improper fraction because the degree of the numerator is bigger than the degree of the denominator, 4 bigger than 2. So what we are going to do here is to divide the numerator by the denominator. So we will do manual division until the result is that until the degree of the numerator will be less than the degree of the denominator. So the result is this. Uh, so this is our quotient and this is our remainder and divisor. Uh, so from this original expression, na-convert na to into this. And pwede na mo integrate that. Yeah. So if we wish to integrate this one, yeah, the problem is reduced to integrating this one. So from the original integrand, na-reduce na saan eh. Oh, integral of x squared dx minus integral of 6 dx plus this one. So this is our quotient x squared minus 6 and this is our remainder divisor. So we'll now shift to this term. This one is just a simple power rule and this one the constant rule. Very basic. So our focus will be on this. How do we integrate this one? This is already a proper fraction. Okay, so in general, we are concerned with the integration of expressions of the form integral of p of x, this is our p of x, 3x minus 23 over q of x, which is x squared minus 4 dx, where the degree of p is less than the degree of q, 1 less than 2. So to do this, it is often necessary to write p of x over q of x as the sum of partial fraction. So we are going to break this down into a sum of partial fractions. So our focus of partial fraction is on the denominator. The denominator of the partial fractions are obtained by factoring q of x. Like, what are the factors of x squared minus 4? So, i-break na to into several factors. So, ang result would be a product of linear and quadratic factors. Depende sa integrand. So, it could be It could be that the product, the denominator will be converted to a product of only linear factors, or only quadratic factors, or a combination of linear and quadratic factors. So, case 1 is when the factors of q of x are all linear and none is repeated. Uh, uh, Again, our focus is on the denominator q of x, that if ever the factors are all linear and then none is repeated, then it falls under case 1. So this one, q of x is equal to x minus a sub 1 times x minus a sub 2 until you have a sub n, where no two of the ai are identical. So, dili pwede na like x minus 1 times x minus 1. No. It means na na-repeat ang factor. Take note that none of the factor is repeated. So, therefore, no two of the AI are identical for case 1. So, in this case, this is our technique. Eh. So, for linear factors, okay, the right side is equal to a sub 1 over x minus a1 plus a sub 2. So, you can use a sub 1, a sub 2 until a sub n, or you can also use the letters in the alphabet like A, B, C, up to the last linear factor, where A sub 1, A sub 2, A sub n are constants to be determined. Okay. This one, name 3 line, it means identically equal for all values of A, or for all values identically equal. So to illustrate, let's evaluate the integral of x minus 1 all over x cubed minus x squared minus 2x. Okay. So let's focus on the denominator. So denominator, we can factor out x. So, okay, the result is this. If you factor out x, the result would be x squared minus x minus 2. Okay. But this term can be broken down into x minus 2 times x plus 1. You can factor this one. X minus 2 times x minus 1. So we have 3 linear factors, x minus 2, and x plus 1. None of the factors is repeated. Okay. So, okay. This is the original integrand, and so we write this one. Okay. Let's convert this one or express this one as a sum of partial fractions, like this one. A over x, b over x minus 2, c over x plus 1. Remember, for linear factors, you only have constant sa numerator. So our problem now is to solve for a, b, and c. Okay. The equation is an identity for all values of x except x equal to 0, 2, and negative 1. Because when x is 0, ma-undefined siya, no? A over 0. Or if x is 2, undefined siya. And also for negative 1, undefined. So para dili ma-define, what we're going to do is to multiply the equation by q. This is our q. So multiply na to like this. Multiply na to sa q. And then, this is the result. So x minus 1 all over this times this is simply x minus 1. And then a over x times this, makancel lang x. So what remains is x minus 2 and then x plus 1. And then b over x minus 2 times this, x minus 2 is cancelled. So we only have x times x plus 1. And then for c, x plus 1 is cancelled. So we have x times x minus 2. Okay. So with this one, we can now substitute the values, the numbers 0, 2, and negative 1. Okay, we already removed the denominator. Okay, so let's substitute when x is equal to 0. The second term is 0, 0 money. And also the third term. So 0 minus 1 is negative 1. Negative 1. 0 minus 2, negative 2. 0 plus 1, 1. Therefore, a is equal to 1 half. And then next, when b is equal to, or when x is equal to 2, the first term is 0. 2 minus 2, 0. As well as the third term, 2 minus 2. And we can solve for b. No? So 2 minus 1 is 1. And then b times 2 times 2 plus 1. And b is equal to 1 over 6. And then when x is equal to negative 1, negative 1, first term is 0, second term is 0, and we can solve for c. Negative 1 minus 1 is negative 2, negative 1, negative 1, negative 2. Sorry. Negative 1 minus 2 is negative 3. And so c is equal to negative 2/3. So the next step is to substitute 1 half, dire, 1 half, 1 over 6, and negative 2/3. This one, 1 half, 1 over 6, negative 2/3. So therefore, the integral of this is equal to the integral of this. So three terms. So our given integral can be expressed as follows. This one is equal to 1 half from this one, 1 half integral of dx over x plus 1 over 6 integral of dx over x minus 2 minus 2/3 integral of dx over x plus 1. ln ang result. This is ln x, and this one, if this is our u, x minus 2, our du is simply dx. So this will be du over u as well as this. U equal to x plus 1, du is equal to dx. So du over u, ln. So ang first term is ln x, second term ln of x minus 2, third term ln of x plus 1. Okay. So, pwede na, no? Actually, this is already correct, no? But if you want to combine all of them, then this is what you're going to do. The biggest denominator is 6, so you factor out 1 over 6. So 1 half divided by 1 over 6 is 3. ln x, 1 and 6 over 1 over 6, 1 lang. 2/3 divided by 1 over 6 is 4. Eh. Okay, so na-combine na. Now, the next step is to convert this one na ln sad, no? Because this is merely a constant. So, we can replace it by 1 over 6 ln c. Anyway, constant lang man eh. Our purpose is para ma-combine sa first group. Eh. But always remember na this is arbitrary. C, same as this. All of the same lang sila constant. So with this, we can combine. No? We factor out 1 over 6. So the result is this. ln of x cubed. By the way, para ma-combine ang terms, dapat wala ang coefficient sa ln. So the coefficient will be converted to exponent. Oh. Naman sa law sa properties of logarithm na a coefficient can be written as an exponent and vice versa. An exponent can be written as coefficient. Like if we say ln of 8 is actually equal to ln of 2 cubed. It's the same as 3 times ln 2. ln of 2 cubed is the same as 3 ln 2. So if you want to compute ln of 8 is equal to ln of 2 cubed and also equal to 3 ln 2. That is why for this one, 3 is converted to an exponent and also with 4 na para wala na coefficient before sa ln. Okay. There's something wrong with this. Wala na yung 1 over 6. Yeah. Wala na 1 over 6. Okay. So, wala ma-delete. So, dapat wala ang 1 over 6. Yeah. So, let's recall sa law of, o sa property of logarithm na ln of x plus ln of y is equal to ln xy. So, and also ln of x minus ln of y is equal to ln of x minus y. So, we are going to apply this one in a step. And this is the final answer. All terms na nag-plus will be multiplied. ln x will ln y multiply. And then with the negative term becomes denominator. ln x minus ln y, ln of x plus y. So x cubed, x minus 2, and c will be multiplied. So we have c x squared times x minus 2, and then this one, the negative term, becomes a denominator. Same with this. So this is the result if you want to combine the answer. Pero, kinina step, this is already correct. This is already correct. Okay, so that is case number 1. Okay. So for linear factors, where no factor is repeated, so it's very simple. Just assign a constant sa numerator for each fraction and then solve lang tayo. And then break the original integrand into several fractions, partial fractions. Okay, that's it. Thank you for watching.